Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning to all. Okay, this video will be explained regarding to example number 5.2, which is it will cover on the last part of the slope stability. Since many of you is not attend during the last class of geotechnical engineering, so I try to come up with this video to give you some explanations regarding to example 5.2. Alright, as you can see here, the question mentions that a cutting is a saturated clay is inclined at a slope of 1 to 1.5 and has a height of 10 meter. Okay, this means your H is 10 meter and there is your bulk unit weight. Bulk unit weight is your gamma of the soil is 19 kilonewton per meter cube. And its undrained coefficients means that 42 is the value for Cu. Okay, determine the factor of safety again immediate shear failure along the slip circle. But it's not only one factor of safety is been, you need to determine the factor of safety. You have three conditions actually in these questions. The condition number 1, you need to ignore the tension crack by using sector angle is 84.06. Means that 84.06, the value is here. Here is the location of 84.06. Okay, and then the area of slip mass adalah 102.1 meter square. Means that area of the slip mass means that here from O to A to B, the original slip. Okay, O, A to B, the area is equal to 102.1 meter square. And the centroid distance from O is 6.94. Where is the location of the centroid distance? The location of centroid distance is from 0, if you can see here, from 0 to W. Okay, to W. D. D is equal to 6.54 meter. Okay, so this one is the first conditions that you need to tackle. Ignore the tension crack. Okay, ignore the tension crack. Means that we consider that this slope doesn't have the crack here. Okay, maksudnya dia adalah original slope lah. Okay, but suddenly mungkin malam tu hujan ataupun hujan panas, then ada certain masa dia akan wujudkan crack kat sini. Okay, wujud crack kat sini. So, in second conditions, we apply ataupun we consider the condition of the tension crack. Okay, we consider the tension crack here. It happens the tension crack, but you just need to ignore the water that fill up in the crack. Means that ignore, so you consider the tension crack is empty of water. And bila tension crack berlaku, indirectly, theta C kita akan berubah. Okay, theta C kita akan berubah. So, kita punya slope akan berada di sini. Okay, so ini nombor 1. Nombor 2, you akan ada kosong AC. Kosong A and C. Means that we have a new value of theta. So, before this, we have a theta here. There is the original theta. So, we have a new theta, which is there is theta C. where the theta C value should be 67.44. Okay, our theta C reduce means that the area pun akan berkurang. Before this, it has been 102. Now it become to 71.64 meter square. And then sama juga the effect to the centroid distance. 0, it will become to 5.86. Okay, dia akan berkurang lah. Okay, so yang ini condition yang kedua. Condition yang ketiga, it's same parameter here, sama saja parameter di dalam condition B, but we consider the crack is full of water. Dipenuhi dengan air. Bila dipenuhi dengan air, crack kita, dia akan menyebabkan overpressure. Pressure pada slope ataupun pressure pada tanah akan bertambah. Okay, sekarang kita try to solve this first condition, which is we just ignore the tension crack. Okay, bila you get this type of questions, means that you need to refer this type of equations. Okay, the factor of safety, F is the factor of safety. Okay, Cu is your undrained cohesion value. And then the R is your radius. Here, there is the R radius. Your L is the sector. Okay, the lilitan value. Or the L can be determined by R theta. Okay, R theta. Okay, and then it should be divided by W, which is W is equal to area times 2 unit weight, and then the D is the centroid distance. Okay, but remember, in using the value of theta in this type of equation, it should be convert to radian value. How to convert the degree to radian? It should be theta times 2 phi times 2 pi. How to convert the radian? How to convert the degree to radian? It should be theta times 2 pi divided by 180. So you get the radian value. Okay, let's go. How to solve this one? Okay, how to determine the R? Since we don't have the R value here, you can determine the R value by using trigonometric concept or trigonometric theory. Where you get here, there is your R, 10 plus 2, 6.7, and then this one is 5 meter. So R should be 5/2 square root. So you will get 17.43 meter for R value. Okay, so you have the Cu, you have the R, you have the L. By using R theta, you don't know the value of W. Okay, so W should be area times 2 unit weight. Okay, area times 2 unit weight. Area is given here, 102.1 times 2 unit weight is, in these questions, your unit weight is 19. Okay, here. Okay, there is the unit weight, 19. So, 19. So, the value should be equal to 1,900 kilonewton. Okay, but if in the questions is not given the value of area, okay, the value of area is not given, how do you determine the area? You can use the area of sector is equal to half times 2 r square times 2 theta. Okay, remember the theta should be in radian also. Okay, so you have the value of Cu, R, L, and W, and also you have the D value. There is your D value. Okay, there is your A, and there is your theta. So F is equal to Cu, R, L divided by WD, or Cu, R square theta divided by WD. Cu is 42 from the equations, okay, and then your R is equal to 17.43 power of 2, and remember your theta should be convert to radian, okay, pi divided by 180 divided by our W is 1939.9 times 2, your D is 6.54. So your value should be 1.48. Okay, this is your 1.48. So how do you determine that your factor SFT is safe or stable or not? You need to compare with the standard factor of safety, which is 1. The minimum is 1. Okay, so 1.48 is greater than 1. So we consider the slope is stable. Okay, so here is the solution for condition A. Okay, now we go to the condition B. Okay, condition B, we consider the tension crack, but the tension crack is empty with water. Okay, so when we talk about the tension crack, you need to add up another new parameter in the equations. Okay, so we will have this type of equation. But since in this condition, there are no water inside the tension crack, so we will disappear this value. So there is 0. PW is equal to 0, so there is 0 value actually. So the final is F is equal to Cu R square theta divided by W. Okay, so in this equation, you have the value of Cu maintained 42. R also there are no changes R. Okay, dia tak ada melibatkan perubahan R. So we use the same R from the previous conditions, which is previous condition R is equal to 17.43 meter, and then you have a new value of theta, which is the theta C. Theta C is here. Here is the theta C. Jangan guna theta yang sebelum ni itu theta. Ini theta C. Theta yang dah kita consider the crack condition. Okay, W, it will be changed because W is equal to A times 2. A berubah since our theta berubah. So, this is our area. Remember, if the equation is not given you the value of area, you can determine the area of sector by using R and theta relationship. Okay, so in this one is W. So W is equal to 71.64 times 2, 19. So our value is 1361.16. Okay, so our F is equal to 42 times 2, 70.3 times 2. Theta is 67.44 times 2 pi divided by 180 divide by your W is 1361.16 times 2, D is 5.86. So you will get 1.88 greater than 1. So your slope is stable. Okay, make sure you comment. Every result you need to comment based on the standard value. Okay, so you have the slope is stable. Your value should be greater than previous conditions because kita punya sektor dah berkurang. Sektor kita dah berkurang, mengecil. Okay, now we continue to determine the condition C, which is in these conditions, remember, you need to consider the tension crack full with water. Maksudnya, you ada crack dan crack you dipenuhi dengan air. Okay, full with water. Okay, so you are using the same equation from the condition B, but for condition B, you just ignore the value of PW times the YC since there are no water inside the crack. But in these conditions, you need to consider the value of PW and YC also. Okay, so in this figure, it mentions that the value of YC is given. YC is equal to 9.58, okay, which is the YC is from the O, from the centroid, until to the part of water pressure. Okay, the water pressure, if you are not given the value of YC, you can determine by using the YC is equal to, okay, from here, this top, okay, it will be have, here is 2/3 of Z0. It is the PW, okay, 2/3 of Z0. So you can determine this one, let's say for this case, 6.8, okay, and then you have the PW here. Okay, so PW 6.7 plus 2, 2/3 of Z0. But in this example, no need to calculate the PW, no need to calculate this, the YC because the YC is given direct to you. Okay, and if in this question the Z0 is given, but if you are not able to have the value of Z0, you can calculate the Z0 equal to 2 times Cu divided by gamma. Okay, now we try to solve the factor of safety for the condition of tension crack when full of water. So factor of safety is equal to Cu times 2R squared theta divided by WD plus 2 PWYC. Where is the unknown value in this equation? Actually, the unknown value for this equation is only PW. How do you determine the PW? Is PW is equal to half power of gamma water times to the Z0. You are referring to the water pressure. So you are referring to the Z0. Okay, so the Cu, the R value, the theta, there is the theta C, the W, the D, and also the YC is given in the question. Okay, the Cu, you are using the 42 times to 17.43 power of 2 times to the theta C should be in radian. Pi divided by 180. Okay. Okay, and then divide by our WD from the previous is Let me check first. Okay, the WD 939. No, this one. Equal to 2 times Cu divided by gamma. Okay, so now we try to solve the factor of safety when in the condition of tension crack, when full of water. Okay, factor of safety is equal to Cu times 2R square theta C WD plus PWYC. In this equation, semua value adalah diberikan. Okay, Cu, R, theta C, R, gunakan R yang sama, Cu yang sama, theta C yang sama. Okay, WD, you are using the same value from the condition B. The YC is given here, but the unknown value is at PW. How do you determine the PW? PW, it should be half gamma water Z0. Why you are referring to Z0? Because this PW is referring to the water pressure here. That's why we just focus on Z0. Okay, so in your case, the Z0 is equal to 4.32. So PW 9.81 times to 4.32. Okay, the value is 21.819. Sorry, 21.19. This is the PW. So you can calculate the FCU is 42 times 2, 70.43 power of 2. Remember, you need to convert to radian. Hour 67. 67.44 times 2 pi divided by 180 divided by W. What is your WD from the previous conditions? Okay, W times 2D. 1361.16 times 2, 586 plus 2, our PW here 21.19, and then our YC given here 9.58. So your F should be equal to 1.7. Okay, you will be get the factor of safety is 1.7, which is this 1.7 is greater than 1, so your slope is stable. Remember, I mentioned before, this condition C, your factor of safety should be less than condition B. Okay, sebabnya sebelum ni you ada crack tapi tak ada air. Means that you tak ada berat tambahan. Tapi untuk condition C, you have a crack with the water. Okay?